Okay, so my name is Malik Yousef from Zifat Academic College. I'm presenting the TextNetTopics, a novel algorithm that based on topics applied in text mining. So the idea is to integrate the topics into the machine learning as a feature selection. Okay, this is the brief idea, but
we need to suggest rules actually. Some non-algorithm like LDA, actually
seeing that there is connection between words. So we would like somehow to use this connection and somehow integrate into the algorithm rather than using just the frequency of the word. So in order to do that, we somehow need the topics to detect the topics and then somehow to integrate the topics. We use the K9 software or platform that actually can process some collection of text, pre-processing, document vector, category to class, and then we have the term frequency, and actually the topic extractor parallel LDA is the algorithm that used in order to extract the topic. So in the end, we will have these topics, this kind of topics. This is just an example. And you see here we have some topics. For example, topic number 0, topic number 1, and each one actually consists from various couple of words. So topics number 4 and so on and so on. So this one actually, the topics are detected by the LDA. Okay. So the next question, how we can use these topics into the machine learning. So now we have the two class text and we have topics. So the question, how we integrate these two things in order to suggest a powerful tool. So in order to do that, we use the topics in order to group the words into groups. Actually, groups here are topics. And then the question, how we score or rank the importance of these groups in terms of classification. That means data like this represented in a bag of words, as a bag of words. And looking to the example, we've seen that some columns that are represent the word, and here are the class label, and the values is the term frequency. It's normalized values, and now we have two inputs: the standard bag of words representation, and we have the topics detected by LDA. So the question, how we can use these two information in order to suggest a powerful tool. In order to do that, we use the topic and the standard representation to extract subdata. This is the subdata that represent only topic number 9. Just an example. So what does it mean? That means we just extract from the bigger or the original data, just a column that actually has the words that appear in topic number 9. So in this way, actually, we'll have subdata, and we keep the class label. And then, actually, we have a subdata that represent topic number 9, for example. Okay, now we have data. If we have data, then the question, how we can find, so if we have data, then we can say, okay, using this subdata, we can somehow give a score to the power of these words in separating the two classes. In order to do that, we just standard machine learning algorithm like this one, that we feed some data, we partition the data into training and testing. For now, we use decision tree or random forest, and then we have a score, the performance, and we repeat this step, for example, 100 times. or 10 times. So in the end, we give some scores, and the score give me information about the power of these words in separating the two classes. So in this way, actually, now we have information which called we score or rank the group number, topic number 9 in this example. Okay, actually the topic ranks algorithm is written in K9. Actually, this is the whole process, and so we have some data that the data consists from positive and negative about 14,000 documents. 15% took for training, 15% for validation, and actually this is the results for training, TextNetTopics and below. We did this 100 times cross validation. And looking to the values, to the numbers, we see that TextNetTopics get reaching very good results. And also TextNetTopics as the result applied in V1, V2, this is the 2 validation dataset provided by the CAMDA community. We also reach very high accuracy performance, and that telling that the tool work very, very, very good. This is actually the results that we obtain when we apply the model in the topic ranking number 1, the significant topic number 1, second and 4, and so on until 10. So as a conclusion, the novel approach that called TextNetTopics work very, very providing very high accuracy performance, and actually there is a lot of direction, future direction in how to using this model, and we have minimized the feature selection and provide more powerful information rather than just using the frequency of the word. Now actually the output of TextNetTopics giving some significant topics rather than just significant words. And if you know the topics, then you actually have an idea about the text. And it's very useful information that was not provided by the other. For listening, it's time for a question.